For over a century, the fundamental way we test medical students, basically grilling them on the spot, has hardly changed at all. Well, until now. Welcome to The Explainer. Today, we're unpacking a really fascinating paper from July 2026 by Dr. Avinash Kumar Gupta, which details an absolutely revolutionary pedagogical shift in medical education. We're going to look closely at the Vibrowns framework, specifically a layer within their clinical cognition operating system known as guided discovery. If you follow how AI is being integrated into complex learning, you already know the landscape is moving incredibly fast. But this framework, it stands out. It fundamentally changes the relationship between the learner, the AI, and the clinical case itself. We're moving from simply challenging answers to actually building them from the ground up. Okay, let's dive into this.
To really grasp this shift, let's contrast two questions that might seem similar at first glance, but actually demand completely different cognitive leaps. Why do you think that? That's your classic Socratic move, right? It tests an answer you've already reached. It kind of puts you on the defensive. But consider the second question. What happens if you change this variable and follow the case forward? That is guided discovery. Instead of just defending a position against an AI persona, you, the learner, are invited into this open environment to explore a case where the answer hasn't even been reached yet. The entire point of the exercise becomes the path you take, rather than just surviving a challenge to your conclusion.
The project actually uses this amazing tagline, describing the intended experience as functioning like an MRI for clinical thinking. And I love that metaphor, because the goal here isn't just to get a fast, confident diagnostic answer out of an AI. Let's be real, most standard prompts can do that. Instead, the aim is to make the normally invisible cognitive reasoning process completely visible for inspection. Just like an MRI sees through tissue to reveal hidden internal structures, this AI framework sees through the final diagnosis to reveal the hidden mechanics of human thought. It's literally about documenting how clinical thinking moves from uncertainty to understanding. And that is absolutely vital for shaping how future doctors make life and death decisions.
So here's our roadmap for today's explainer, taking us from the macro concepts all the way down to the micromechanics. First, beyond the Socratic method. Then 2, modules, agents, and pipelines. Third, the 6-stage discovery journey. Next, analytics mode in action. And finally, 5, current limits and future validation.
All right, let's start with Section 1, Beyond the Socratic Method.
The crucial point to understand here is that the Vibrowns framework operates on a 5-stage spectrum. It moves from instructor-centered transmission all the way to learner-centered inquiry. Socratic learning, that sits at stage 3. It essentially asks the AI to hold a single line of questioning against a learner-stated position. But guided discovery pushes us further to stage 4. This is a massive shift from just testing existing answers to actually constructing scaffolded environments for active exploration. Think of it like being an architect of experience. Instead of just putting a learner on the defensive, you build a safe, scaffolded sandbox for them to explore. Through a tiered hint structure, the AI provides a framework, narrows the direction, and acts as a guide through multiple cognitive lenses. It treats the struggle of exploration as the most valuable part of the whole exercise.
Moving right along to Section 2, modules, agents, and pipelines. So instead of just relying on some massive copy-pasted persona prompt, guided discovery uses this really elegant 3-level composition engine. The foundational building block here is the module. This is defined as a single cognitive lens applied once to a case, offering a focused pass on one aspect of the reasoning problem. The framework actually has a library of 57 of these modules, and they are highly specialized. For example, running a bias detection module acts like a tripwire. It catches a learner if they anchor too early on a patient's chest pain without exploring other vital symptoms.
Now watch how these blocks stack together to give educators literally unprecedented control. Level 1 is the module we just talked about. Level 2 introduces agents. These are specialized orchestrations that internally select and sequence multiple modules for you. And then at Level 3, we have pipelines, which are explicit, ordered sequences of modules and agents. This hierarchy is brilliant. It gives you a precise style to control the breadth and depth of a clinical exploration. You can run one quick focused module, or you can string together an elaborate pipeline that walks a complex case through a progressive, multi-stage reasoning journey. And the sequence matters heavily here, folks. Running a safety module before a reasoning module produces a materially different outcome than doing it in reverse.
Which brings us to Section 3, the 6-stage discovery journey.
When you string these modules together into a pipeline, the framework outlines a very specific, structured sequence called the discovery journey. Let's walk through it.
Imagine a patient presents with sudden, unexplained fatigue. Step 1 is observation. You simply take in the raw history and labs without jumping to conclusions. Step 2 is pattern recognition. You realize the fatigue clusters with a surprisingly low red blood cell count. Step 3 is hypothesis generation, where you build a list of possible diagnoses based on those specific clusters. Step 4, decision architecture, maps out how your hypotheses relate to an actual clinical decision, like ordering a specific follow-up test. Step 5 is bias detection. This is an automatic cognitive audit, catching failures like premature closure, say assuming it's just an iron deficiency without checking other markers. And finally, Step 6 is metacognitive reflection. This is where the learner audits their own thinking process. They reflect on how their understanding developed, not just what diagnosis they landed on. It's a complete, totally visible roadmap of clinical cognition.
Next up, Section 4, Analytics Mode in Action. So how does this actually work? The framework operates on this beautifully minimal interaction pattern called analytics mode, and honestly, the best part? Zero custom software required. None. A learner literally just takes a clinical case, pairs it with a reference, and submits it as a single instruction into a general-purpose LLM chat interface. The scope of this invocation scales perfectly too. You can submit a single module for a quick check, like running module 42 for a clinical premortem, or you could submit a targeted pipeline, running a sequence like modules 1, 12, 9, 21, and 35 back-to-back. If you want maximum autonomy, you just invoke the full guided discovery agent. That internally parses the case across 8 structured dimensions and scores the entire module catalog before running. It all scales smoothly using the exact same underlying mechanism.
Finally, Section 5, Current Limits and Future Validation.
Now, to be completely objective here, according to the framework's own domain maturity summary, the guided discovery layer is currently rated at medium maturity, not demonstrated maturity. So while the Socratic learning layer is considered high maturity with live deployments, the guided discovery research domain has a completed single worked case example right now. But multi-case validation is still entirely pending. The instructional design is thoroughly documented and functional, sure, but we have to recognize that it lacks repeated measures evidence across controlled comparisons at this time.
And the source material is super candid about why this is, detailing some very specific structural limitations. First off, there is no machine-enforced pipeline grammar. Right now, any sequence of modules is syntactically valid, even if it doesn't make logical sense, meaning learners kind of have to rely on heuristic aids to build pipelines. Second, handoffs between modules use free text rather than schema-validated structured data. That makes aggregating data across cases pretty difficult. And third, there's generative variability. Running the exact same case through the exact same pipeline might yield slightly different outputs. Because of these engineering gaps, the framework clearly states that these outputs are currently learning artifacts. They are not validated clinical or research conclusions.
But, even when we acknowledge those current engineering limits, the core concept here is undeniably powerful, which leaves us with this final, rather provocative thought. How might making the invisible reasoning process visible change the future of all complex learning? Think about it. If we can successfully build an MRI for clinical thinking, breaking down observation, bias, and metacognition into a scorable, visible pipeline, imagine what this guided discovery architecture could do for law, for engineering, or for scientific research. We're moving from AI that just spits out the answer to AI that actually teaches us how to think. It's a massive shift and definitely something to keep an eye on. Thank you so much for joining me for this explainer, and I can't wait to explore more fascinating topics with you next time.